Well, well, what has the cat dragged in today? It's a bonus tutorial video on Unity. So we have here our completed space game. Simple as it is, it's still a completed project. Congratulations, good job. You made something in Unity. Admittedly, it's a pretty simple something, so let's try and spruce up the gameplay a tiny bit. Nothing fancy, just a little bit of extra polish on here to make the gameplay more entertaining. I want the spheres, or the rocks, to rotate. So in other words, I have moving hazards. I want the rocks to move. I also want to make it so that the ship can take more than one hit. Because currently we have it set up so one hit and you're done. That's it. Boom, you're gone. Game over. I want to be able to take at least a couple hits, tweakable in the inspector, before it's game over. So let's get the asteroids, the rocks, moving first. Now there's a couple of ways that we could approach this. We could get all fancy and having them streak back and forth and wraparound systems and all sorts of shenanigans. Or we can go really, really simple. All I'm going to do is I'm going to group these up and I'm going to have them rotate around a central game object. So what I'm going to do is, first things first, I'm going to zoom in and look at these here. Actually, you know what? I am going to adjust my widget here so that I am looking at this in orthographic mode. And I suppose I should narrate that just in case you are unfamiliar with how to use this widget here. What I did is first I clicked on the square to change from perspective, as you can tell by the vanishing point, to ISO, technically, as you can tell by these lines. And then I clicked on Z, and then I clicked on Y to basically be perfectly looking down, as it says here, I'm looking down at the tops of everything, just to make it a little bit easier to position objects. Now remember, in this mode, you don't right-click WASD to navigate around. You use middle mouse wheel drag or arrow keys to move around in this mode. That's important to remember, because if you try to do right-click drag, oh no, I am an ISO, no, this is terrible, I'm horribly confused, let me out. So I'm in top view, looking at these, and it's purely optional. You could do this through perspective too. I just like working in this mode a little bit better. Okay, so I am going to create an empty game object. So I'm going to use the shortcut Control-Shift-N. I'm going to call this Rock Center. And I am going to roughly position this in the center between these three here. And so what I'm going to do next is, actually I'll probably open up a second hierarchy window here. So I'm going to, on Inspector, I'm going to right-click, Add Tab, Hierarchy. It's very useful sometimes to do this, because what I want to do is I want to lock this hierarchy window. So I'm going to lock it. That way I'm always on Rock Center. And then, or at least I'm always showing it in this view. I'm not expanding it out. So I can select these and drag them cross window over like that. So again, to repeat, I've locked this hierarchy window so it doesn't expand. On my other hierarchy window, I can perfectly see where I've selected the three rocks that I've selected. And I'm going to left-click drag. I suppose I could do it there, but left-click, drag it over. A bit needlessly complicated, but I wanted to show locking and dual hierarchy windows because this can be a very useful tool in more complex projects. A bit of an overkill here. I could have just as easily just selected and moved them. All right, so I'm going to close my hierarchy. So I'm going to right-click, close tab, get rid of that. I don't need that second window. So now I have this rock center. And what that enables me to do, I'll go ahead and leave orthographic here. I'm going to switch back to perspective. If I rotate these around the y, so y is going up, so if I rotate around the y-axis, they do that, which is pretty much exactly what I'm looking for. So I'm going to reset that rotation back to 0. So what I need is some way of automatically doing this. Well, hey, that sounds like a job for a custom script. So I am going to go to Project. I'm going to make sure that I'm in my scripts directory. Again, not necessary for functionality, but a really good idea. I am going to right-click, Create, C# script. I'm going to call this Simple Rotate. I'm going to remember to immediately attach this to my game object. So I'm going to drag it up onto my rock center. And then I'm going to double click on the script to open it up in Visual Studio. Now, if you didn't already have Visual Studio opened up, you might be waiting on it. So pause the video if necessary, wait for Visual Studio to load, and then unpause the video. And with that, I'm assuming we're all good to go. Just like in the ship controller, I don't actually need to do anything on the start method, which is the very first frame before the first update call is made. So I'm just going to delete out this code to keep things clean. I am going to want to put in a class level variable for much the same reason I did it on the ship controller. This is a value that I want to be able to tweak, the rotate speed. How fast will this rotate? And I might want to have different groupings of rocks rotating at different speeds. If I hard code the number, that won't work. So I need a variable. So public, because I want to be able to see this in the inspector. What is the data type? Oh, I potentially want to have a floating point number. So float. And the name of the variable I will call rotate speed. And I will set its default value to 90. It's important to remember, what does this represent? This represents degrees per second. At least that's what I want it to be. So I've got to make sure that's reflected in the code. Update. What do I need to do in update? Again, anytime that we are modifying a game object's position, rotation, or scale, we are dealing with transform. Lowercase t transform, the transform property that is associated with a mono behavior. So lowercase t transform dot. Now, what do I need to do here? Well, I need to rotate this. And thankfully, there is a built-in rotate method. Unfortunately, there's a couple of legacy options here that could potentially confuse you. The option that you want is capital R rotate for this scenario. Open parentheses, because this is a method. Now, there's 6 different versions of this. If you want to cycle through the versions, you can use the mouse to click on these up and down arrows to cycle through the different versions. The version that we are going to use is 2 of 6, where we tell it what axis do we want to rotate around, because we know that it's the y-axis, and then in degrees, that's a very important thing to keep in mind for later on. In degrees, how much should we rotate? So I want the up axis, the y-axis. Thankfully, this is predefined for us. I can go to capital V vector 3 dot up. This is a predefined vector of the value 0, 1, 0 that basically defines the y-axis. And then for the angle, I'm going to want my rotate speed. But just like our ship movement speed, we need to scale this. If I left it like this, I'd be rotating 90 degrees per frame, which would be absurd. I want 90 degrees per second. So I want to scale this by time, capital T time dot delta time. And that time dot delta time, again, is what converts my units from per frame to per second. Save the code. I have a functional piece of code. I want to test this. Now, obviously, not all of my rocks are going to rotate. The only ones that are going to rotate are these 3 in the corner here that I set up. Hit the run button, and there we go. They are rotating. Now, do they still properly kill me if I stick my nose up here? They do. Excellent. So now what I can do, honestly, is I can come into my rocks collection. I'm actually going to delete out all of my old rocks. Move this rock center back into that collection. And now I can duplicate them out. Now I've got to be careful. I would not want to put it right here, because within like a half second to a second of the game starting, the player would be killed. So I do have to watch out for that now. Oops, nope, that is the wrong axis. So I'm just going to duplicate some of these out. And then I'm going to want to play test. I might have put too many in. Woohoo! Thread the needle. And there we go. You win. Of course, I could make this easier or harder by slowing down or speeding up how fast things rotate. Or I could even go through, as long as I'm selecting the rock centers, I can adjust it. So like, maybe this one rotates a little bit slower, and this one rotates a little bit faster. And, I'll leave that one where it is. And this one can be a lot slower. That makes for a little bit more visually interesting setup. And that's it. That little bit of extra gameplay, which makes this game vastly more interesting. Still fairly simple, but in my opinion, it makes it vastly more interesting having to dodge the rotating rocks, the rotating asteroids, versus just weave your way through the static ones. All done with what's effectively 2 lines of code. 1 line defining a variable that we can access the inspector, and 1 line actually telling it what to do every frame. That's it. Code doesn't need to be complex to make interesting things happen. Now, the other interesting thing that we want to have happen is I don't want the player to die instantly. And for that, we're going to have to come back over to the ship controller. Now, if you don't already have this script open, just simply go over to Unity, go into your scripts directory, and double-click on the ship controller script. Make sure that this script is loaded and ready to go before continuing, so pause the video if necessary. What I need to do is I need to insert a new piece of data and modify the functionality of onCollisionInter. The data that I need to track how many lives, air quotes, do I have. Maybe shields would be a better representation, or armor, or health, something like that. I need to track how many times can I get hit before I die. So for the data, now this isn't, now when you're doing variables, we got to ask ourselves, is this a variable that is recalculated every frame and I don't need to remember? That's the case here for ship offset. I don't need to remember this from frame to frame because I'm calculating it every frame. But in the case of my health, I'm not calculating my health every frame. I know what that number is, and it needs to persist across multiple frames. When that is the case, you need a class level variable. So I'm going to come back up here to the top. Again, this is not functionally required, but it's considered a general good practice to put all of your variable declarations at the top. And I am going to declare an int. I'm not going to make this public. Nope, never mind. Sorry. I do need to make this public. I don't care. I mean, I'm probably not going to be modifying this too much, but I do want to be able to modify this. Like, do I want to be able to hit 2 times, 3 times, 4 times, whatever? So I do want this public. I do want this showing up in the inspector. I'm going to make it an integer this time. I'm not going to have fractions of a life. It's like I can hit 1, 2, 3, a whole number of asteroids. I can't hit 1 1/4 asteroids. No, that doesn't make sense for this particular system. And I'm going to make it shields, and I'm going to set the value to 1. Now here, if I can actually type, that would be lovely. Here's where things get really interesting. There's a lot of different ways that we could represent this value. In this particular case, my logic is going to be, I am hit. Do I have shields? Yes or no? If yes, reduce shields, destroy the asteroid. If no, display you lose, destroy the player. And sometimes, not perhaps necessary for this simplistic of an example, but if I'm doing complex logic, I'll actually write out in plain English what it is that I want to do. So comments are done by 2 forward slashes. Check for shields. If shields, reduce by 1 and destroy rock. No shields, kill player and show you lose. So those are my actions. Now, if you don't want to type in the comments, you do not have to. Comments have no impact at all on functionality. But I'm going to use these as a guide for modifying the code. Check for shields. How do I ask a question? Are my shields greater than 0? That's the question that I want to ask. When asking questions, the most common way in C#, of course, is the if statement. So I'm going to do if, open parentheses, shields greater than 0. So if my shields is greater than 0, this will return true. So I'm going to hit the enter key and put in a curly brace. I'm also going to move my comment. So Control X, Control V. Oops. Control V, thank you. Just to keep it inside my parentheses. Again, the comments are not necessary. If shields, reduce by 1 and destroy rock. Okay, I need to reduce my shields by 1. Shields equals shields minus 1. Same thing we did with the transform. Take my current value, subtract 1, store the new value back into the variable. And then I want to destroy the rock because otherwise it's going to cause weird things with the behavior, because we can't have the ship interacting with physical objects. It would cause issues. Now, how do I destroy the rock? Well, that would be found in this collision variable that I have. This represents the information of the object that I hit. So this is on the ship. The thing that I hit was another rock. So I am going to say destroy collision dot game object. Destroy the game object that I hit. Now, there's no additional logic. Either my shield is greater than 0 or my shield is less than 0. So I don't need another if statement here. You could put another if statement in, but it would be better, I think, in this case, to keep things simple. And I'm just going to write else. Hit the enter key, put in my curly bracket, hit the enter key. Again, I'm going to move my comment. Not that the comments are necessary to instruct me. Now, I already have this logic. It's this logic right here. So I am going to select these two lines and copy paste them and clean up my spaces there. So this is now what on collision enter looks like. We check for our shields. If shields is greater than 0, open curly bracket. We then subtract 1 from our shields because we still have shields. So let's lose 1. So we're going to subtract 1 from shields, store that back into the shields variable, destroy the thing that we just hit. If we don't have shields 0 or less, although it should always be 0, and we hit something, well, oops, we're going to print you lose and then destroy it. If you have any red squiggles of doom at this point, make sure you fix it. Also, make sure that your indentation looks like mine. Indentation does not matter in C#, not functionally. But a common error that I see with first-time C# programmers is they do not include the curly brackets. Now, do not do what I am about to do, because this is going to be wrong. A common error is for them to do something like this. And if you let auto format do its thing, it'll actually auto format it to look like this. And this is wrong because without the curly brackets, it's still syntactically correct. But only this line is associated with the else statement now. That means our lives are pointless, we'll always die anyways, because this line will always be executed. For new C# programmers, I immensely, strongly recommend that you always use the curly braces to encapsulate your if, else statements, even if they're a single line. Always use the curly braces. It just helps avoid potential errors. Okay. My code is written. My file is saved. I have new functionality to test. Let's see if it works. I should be able to take 1 hit before I die. I'm going to rush in here. Took 1 hit. Didn't die. Took 2nd hit. And I died. And I know it looked like I did get hit there, but the perspective makes that really wonky. And then I want to test to make sure that I can still win. So I will get my hands on the right keys. That would be helpful. I'll take a hit. Victory. And I want to make sure that I can still win, taking no hits. And I can. And I can adjust, how many hits can I take. So if I come over here to my ship controller and increase my shields to 3, well, I mean, it completely removes any challenge because now I can just go, 1, 2, 3. Yep, okay, I'm good. and there was the fourth rock, and I died. Okay. And that's it. Now, before I close out the video, a little bonus game. What bug did we just introduce to the game? It's a pretty big one. Comment below if you think you can figure it out. All right, if you have liked this video or thought you learned something, thought it was entertaining, thumbs up would be appreciated. If you didn't learn all that much, well, the thumbs down button is right next to it. Until the next video.